Hi, and thanks for your interest in how I built the Magnorail model. A lot of people have been asking about how to use magnetic reed switches to control the Magnorail track and the positioning of the vehicles around it. For those of you that aren't familiar with a reed switch, this is what a reed switch looks like. It's a little glass encapsulated device with two wires coming out of it. They're extremely cheap to buy, literally just sort of about 50 cents a piece, and you can get them on eBay. They're quite fragile, so you have to be very careful indeed when you're bending the wires that you don't damage the glass capsule. So bend the wires at least 3 or 4 millimeters away from the glass, and then in that way you won't crack the glass. But this is quite an important thing to ensure. So you position the reed switches at the side of the track in very close proximity to it. Now, under normal circumstances, the magnets on the chain should operate the reed switch. But to be absolutely certain, it's a good idea to, in addition, mount a couple of additional magnets behind the vehicle magnet, but this time to polarize them north and south, left and right, in other words sideways, whereas of course the magnets for the vehicles are polarized north and south, up and down. So these additional magnets are an extra precaution to make sure that you get a positive signal come through. So once you've decided on exactly where you want to position the reed switches to signal the position of the vehicles around the circuit, that's when you need to solder a couple of wires onto the reed switch. Then have a good look inside the glass and turn it so that the actual blades of the switch are facing the sides of the channel. Then you can bend the wires vertically to feed through a couple of holes in your baseboard. Once you've done that, it's important that the whole thing is very firmly fixed in place, so there's no question of any movement. And the best way to do this is to encapsulate the whole thing in a blob of epoxy resin. Making sure, of course, that the resin doesn't leak through the little gaps in the Magnorail channel into where the chain runs, and that would inhibit the running of the chain. So just put a little strip of masking tape or something along there before you pour the epoxy resin in. I also marked with a little label what the name of that switch is and what it did, so that I would know exactly where to route the wires. So that is the best way to fix the little switches along the side. And you can now see in the next shot some of these switches located in place. That one, for example, is the one that tells the ambulance where to stop on the circuit. That cues some of the special effects. Further along are the parking switches that stop the ambulance and the cycle in their parked position. Now, obviously, you don't actually control the Magnorail motors directly from the reed switches. You need some kind of device as an interface, and this is where I've used little Arduino computers. These are very, very cheap and cost effective, and if you buy the Chinese rip-off versions, about a quarter the price of the originals. One thing to bear in mind though is that they take about 4 weeks to arrive on a slow boat from China, so you've got to bear that in mind when you're scheduling your project. Now, I've shown this Arduino here with a prototyping board. This you don't normally use in the finished result. You would use what is known as a shield, and a shield is a sort of printed circuit board that plugs directly into the top of the Arduino. This is a shield, and you solder your leads onto that board together with other peripheral components, the most important of which is known as a pull-down resistor. That's the pull-down resistor being pointed out there. The purpose of the pull-down resistor is to ensure that when the reed switch opens, the signal is fully earthed, and the pull down resistor makes sure that the Arduino realizes that the switch has in fact opened. Now, Arduino boards are fairly straightforward and simple to program. There's plenty of tutorials on YouTube and various other places to tell you how to program these things. And they are so cost effective that rather than try to control everything from one Arduino with a very complicated code, it's best to use several Arduinos and just use one to drive all your Magnorail stuff, and then other Arduinos to work the special effects or the animations or lighting or sound effects or whatever else. If you're interested in the coding and you have any problems, then just let me know. Now, the one thing that I do want to share with you that I had a big problem with, and that is what you can see there, which is the road surface. I took people's advice and I used photo paper, glossy side down, and I'm sure for most applications this is fine. But the problem that I found was that if, when you start to do the landscaping, you have any moisture from any plaster or water-based paints in proximity to this card, it can at best cause the glossy surface to become tacky and cause the magnets to sort of judder as they go along the underside, and at worst cause the actual card to delaminate and disintegrate. And I had a lot of problems with this, particularly the little narrow pathway that you can see there that the cyclist comes down, where although the plaster never actually got anywhere near the Magnorail channel, it nevertheless caused the glossy underside surface to cause the magnets to drag. So I had to rip it up, which was a bit of a messy business, particularly as I'd done all the landscaping around it, and replace it with a polycarbonate sheet. Now, people say you shouldn't use plastic for this because it has a tendency under hot lights to buckle and disintegrate. But I found that polycarbonate is fine. It didn't give me any problems. I tested it first, and it gives a good finish. So, thank you for watching. I hope you found this interesting. If you've got any questions or any queries, do let me know, and please like and subscribe to my channel. So thanks for watching, and bye for now.